Hello everybody, my name is Asemota and I am a pencil partner working on the virtual learning series through Hands-on Nashville. Last video we learned about solving equations that have more than one variable present. Today we'll learn how to solve for variables that have exponents applied to them. Before we begin, allow me to remind you to stay quarantined, keep yourself hydrated, and get tested if you show symptoms. Now, let's talk math. Just in case any of you don't know already, let's firstly go over what exponents are. Exponents are special symbols that represent operations. They are written as a small number to the top right of a number or variable that they are applied to, as we can see here. An exponent applied to a number causes the number to be multiplied by its own value for as many times as the exponent denotes. These exponents are expressed in words as to the power of the number they are applied to. For example, we have this 3 with an exponent of 2. It can be expressed as 3 to the power of 2, and it represents 3 times 3. Therefore, 3 to the power of 2 equals 9. 3 to the power of 3 to the power of 2 is also known as 3 to the second power, or 3 squared. A number to the power of 3 can be expressed as a number cubed, but all numbers higher than 3 follow the other naming patterns. An example is 5 to the fourth power. The exponent 4 makes 5 multiplied by itself 4 times, resulting in 625. Exponents can cause a number to grow quite dramatically, as we can see in this example. With each exponent step, the number grows faster and faster. This is known as exponential growth. Some other important notes of exponents is that a number to the first power is just the number itself, and any number to the power of 0 equals 1. How do we solve for these exponents? Exponents and values resulting from these exponents can be solved using roots. Roots are written as checkmark-like figures, but they can also be written as exponents themselves. The second root, also known as a square root, can be expressed as a exponent 1/2. This 1/2 cancels out the exponent 2 and returns the original value. With this, we see that the square root of 9 equals 3, and 3 was the value we had in the first place. But we see that it's plus or minus 3. Why is that? That is because negative 3 times negative 3 equals 9, just as positive 3 times positive 3 equals 9. So taking the square root, or taking any even root of any number returns two possible values, a positive one and a negative one. Just as we see here, the fourth root of 625 equals plus or minus 5. This isn't true for odd numbers, however. They can have negative square roots. Even roots can't have negative numbers inside, as it's impossible to get a negative number for multiplying any number by itself. So, what if we have variables with these exponents? Solving for these variables, if it's just the variable itself, is pretty simple. We just have to use the same method of isolating the variable on one side of the equation, and then we use the final step of taking the root of it. So in this case, we take the third root. In this case, we take the square root. Let's look at some examples. We have the equation a squared equals 49. Well, what we want to do is take the square root of both sides, and we get square root of a and square root of 49, and that result in a is equal to plus or minus 7. Now, this plus or minus 7 are two different results. It's going to be a positive 7 and a negative 7. So this a has two values. And next we have b squared minus 7 equals negative 32. So we want to isolate this by adding 7 on both sides, and we get b squared is equal to negative 25. Take the square root of that, but there is no number that, when multiplied by itself, that gives us negative 25. So b does not exist. And thirdly, we have c cubed equals negative 64. We take the third root of both sides, and we get that c is equal to negative 4. This is fair game, since if you multiply a negative number by itself an odd amount of times, it will still be negative. And taking the roots of these numbers by hand is difficult, and you basically have to know them. So you'll want to have a calculator when you're doing these problems. So solving for these variables is pretty simple. But what if the equation contains variables with differing exponents? If this is the case, the simple method of isolation won't work, as the variables won't be able to combine with each other. If the highest exponent is 2, there are two methods we could use to solve for the variable. Solving for these variables will produce two values for the variable, except for in special cases. Before solving for the variable, we must put all the elements on one side of the equation. It doesn't matter which side, but mostly the left side is used. So, putting all variables on the left side of the equation and combining like terms will return the equation in the form a times x to the second power plus b times x plus c equals 0. And x is just the variable, and a, b, and c are constants that are applied to the variable, and c is just a number that's also in the equation. Let's look at the equation below. We have w squared plus 4 equals w plus 6. We want to get all the elements on the left side by doing minus w minus 6 on both sides, and that will give us w squared minus w minus 2 equals 0. And so we'll have the constants a is 1, b is negative 1, and c is negative 2. Now, how do we solve for this? The first method of solving for this is known as the factoring method. This method involves factoring out the equation so we can find solutions to the variable. The idea is that the equation is formed from two distinct solutions of the variable, and we can identify those solutions by finding values of the constant b and c. With this method, the constant a, or in other words, the number in front of the variable with the power of 2, must be 1. The factoring method will not work if there is a number besides 1 in front of the squared variable. Another rule that must be true is that the roots need to be whole numbers. If they aren't, you won't be able to find the solutions with this. To find the factors, we must find a pair of numbers that add up to the constant b and multiply to the constant c. It sounds a bit confusing, but let's look at the equation we just had. W squared minus w minus 2 equals 0. So we have a is 1, b is negative 1, and c is negative 2. We need to find a pair of numbers that multiply to c and add up to b. We want to find c first because there are only a few ways to multiply whole numbers to get a particular number, while there is an infinite amount of ways to add or subtract new numbers to get a particular number. So we know that c is negative 2, and there's only two ways to get negative 2 with whole numbers, that being 1 times negative 2 or negative 1 times 2. And these differing negatives do matter, because as we can see, 1 plus negative 2 equals negative 1, but negative 1 plus 2 equals 1. And since b is negative 1, we'll want to take the 1 plus negative 2. And since we'll have those, we'll have the solutions that y is y minus 2 times y plus 1 is equal to 0. We factored out the 2 and the 1. and we set these equations separately equal to 0. Y plus 1 is equal to 0, and y minus 2 is equal to 0. And we isolate them to get y is equal to 2 and negative 1. So that's the factoring method. But what's the other method of solving? The other method of solving the equation is the use of the quadratic equation. The quadratic equation is a defined equation that returns the solution of the variable when the constants are inputted into it. It is a somewhat complex equation, so you'll definitely want to have a calculator until you're comfortable with just solving it with your hands. The complexion is worth it, however, because the quadratic equation can solve for any variable regardless of what the constants or solutions are. Let's look at this equation again. So we have the same equation here, but the quadratic equation is negative b plus or minus the square root of b squared minus 4 times a times c, and all of that over 2 times a. That's complex, but all we have to do is input these values into it. So we get negative 1, which would become positive 1, plus or minus square root negative 1 squared, which would be 1, positive 1, minus 4 times 1 times negative 2, and negative 4 times 1 times negative 2 be positive 8, divided by 2 times 1, so that would be 2. So that will give us 1 plus or minus the square root of 1 plus 8 over 2. And 1 plus 8 is 9, so that gives us 1 plus or minus 3 divided by 2. And we separate the plus and minus into two different equations. 1 plus 3 divided by 2, and 1 minus 3 divided by 2. And this gives us 4 over 2 and negative 2 over 2, which will give us the same solutions we had. Now, let's test your knowledge. So we have the equation d squared minus 1 equals 5 plus d. So we want to start by, ignore this. We want to start by having by subtracting 5 and d on both sides, so we can get the equation in the form a x squared minus x bx minus c. And since a is equal to 1, we can use the factoring method. And we'll see that a is 1, b is negative 1, and c is negative 6. And we want to solve for c first. And since c is negative 6, it can be 1 times negative 6 or 2 times negative 3. And we will know that the bigger number is negative because b is negative. And with this in mind, we know that b is negative 1, so it must be 2 plus negative 3. And so we have the solutions d plus 2 and d minus 3 equals 3, and that will give us d is equal to negative 2 and d is equal to 3. In the second equation, we have e squared plus 6e plus 8 is equal to 0. It's already in the form we need, so we can just find the constants. A is equal to 1, b is equal to 6, and c is equal to 8. And 8 is either 2 times 4 or 1 times 8. And b is equal to 6, so we know that it must be 2 and 4, since 2 plus 4 is equal to 6. And we have the solutions a plus 2, e plus 2, and e plus 4 equals 0. We solve them separately, and we'll get that e is equal to negative 2, and e is negative 4. And next example, we have 3e squared plus 3e is equal minus 90 is equal to 0. And in this form, a is not 1, so we have to use the quadratic equation. And so we input all these values in. Negative 3 plus or minus square root of 9 minus 4 times 3 times negative 90 over 2 and 3. These numbers are quite big, so you're going to want to use a calculator. We'll see that this is the square root of 9 plus 1080, and that is equal to 33. So we'll have 3 plus or minus 33 over 6. And that will separate into two equations here. Negative 3 plus 33 over 6 and negative 3 minus 33 is equal to 6. We simplify and we'll get that e is equal to 5 F is equal to 5 and negative 6. I hope you learned something.